Welcome back. We saw last time how to create materials and assign them to both objects and individual parts of a mesh. Today we are going to take an important step forward instead and look at the use of nodes. In Blender, there is a special layout designed specifically to help us when we want to define a material. This is the layout called shading that we find up here at the top. So we click and we get a completely different layout. But as we have seen already from the very first lessons of this course, we know that it is always and exclusively Blender. So let's not be scared. We simply have multiple windows with different editors. Here in the center, we always have the 3D viewport in which the shading method called Material Preview has been set. We see that there is a background instead of the classic gray background we see like some kind of image. Then here we have the file browser, we have the image editor, and down here we have the shader editor. This is the node editor. Let's go over here to the right in the properties window to the material section. We have our default material. We saw last time how to delete it, create new ones, etc. And we saw how we can define some parameters within the surface subsection. Let's take an example. Let's take this white color to red. We see that our cube has turned red. And we see that here within the shader editor something has also changed. That is, the base color parameter has also turned red. We notice that here on the right, we have the exact same parameters that we find here within the node called principled BSDF. There, basically everything that we can do here on the right, we can also do here within the node editor. With the difference being that here we will be able to view all the concatenations of the nodes that we are going to insert, whereas here on the right it would be a lot more effort. So here, let's say, is the ideal place to go and change some parameters on the fly, but it's here within the shader editor that we're going to do the bulk of the work, and we're also going to see how materials can get very complex to make. So always remember, the parameters we see within the material section, we also find within the shader editor. Before we start, let's give ourselves 2 minutes to understand what nodes are. Imagine these little rectangles that we can select. Move simply with a click of the mouse. We can zoom in to get closer. Click the mouse wheel to pan. Here, imagine these objects as little pieces of code, real subprograms that take information from the left side, process it, and throw it out on the right side. Each of these little dots that we see are connectors that, if they are on the left side, are for importing information. If they are on the right side, are for exporting information. So this node, so full-bodied, structured with so many options, and if we expand all of them, we will see that there are so many has a whole series of inputs and only one output. Each dot corresponds to a different type of data, which also alerts us when we are doing something wrong. In fact, when we go to connect a purple dot with a green dot, for example, something may not work or otherwise not give the result we expect. The coloring was given by the programmers precisely to help us not make mistakes. Let's look at these colors together. Yellow indicates color type information, that is, RGB information. If we let go of the mouse pointer, we are also given information. You see color of the material used for diffusion, subsurface, metallic, and transmission. We will see later what they are. Specifically, the color right now is 0.8001, etc. 0.006, 01. What are these colors? You see they are a group of 4 values. The first indicates the amount of color in the red channel. The second is the amount of color in the green channel. The third, which is 0 in this case, is the amount of color we find in the blue channel. While the last color, which in this case is 1, indicates the transparency of the image of the color you are going to use. 1 means it is completely opaque. 0 completely transparent. However, for now, don't be frightened. Know that the yellow dot means color type information, i.e. 4 pieces of numerical information that together result in an image. In this case, a flat colored image in red color. Then we have the gray type connectors. These are simple numeric type connectors. If you are a programmer, you can see that this is a float type data, a value with a comma and not an integer. Here we see it set to 0. Depending on the type of material, there can be minima and maxima. In this case, the minimum value is 0, the maximum is 1, and if we put an intermediate value by holding the mouse over the connector, we can see the precise value. In this case, it is 0.7977273. Now, the other connectors also are gray, so they expect a value like float. True, in this case, for example, in the value metallic, we have from 0 to 1, however, no one forbids to use negative values, or at least higher than the number 1. It depends on the context you are in. In general, however, gray dot secures a numeric value with a comma. We then have the purple connector. This is a triplet of numbers. In this case, we find 0, 0, and 0, which define a vector. There are 3 of them because they are 1 for each axis. The first value is the x-axis, the second is the y-axis, and the third is the z-axis. So when we see purple dots, we will know that we are talking about a triplet of values defining a vector. If we go to open the subcategories transmission, emission, etc., we see that the color of the dots is always that, either a gray, a yellow, or a purple. However, there is also an additional color, which is the green color. The green type connector is not just numerical data, but it is information that defines a shading, a shader, that is the material. When we connect a green dot with another green dot, we are transferring real information inherent in the material, so it is not a simple numerical value. Within Blender, we mainly find 3 types of nodes: input type nodes, intermediate nodes, and output type nodes. The input type nodes, we see them by invoking the add command with Shift plus A, are several. Let's take one, for example, object info. You see that they do not have input values, but they only have output values. This is because these nodes are only used to give us information, and in this case, object info is information coming from our object, for example, location, color, etc. Intermediate nodes are, for example, principled BSDF. However, all those nodes that are neither input nor output are intermediate nodes, so they will have both input and output information. Finally, we have the output type nodes, which, unlike the input type nodes, have only input information and no output information because they receive the information from our node system and return it to Blender in the form of material. So the material that we see inside the 3D viewport will be what we get from the material output. To insert a new node we have just seen, you use the add command, which is always called with the abbreviation Shift plus A. Perhaps do some free experimentation, insert nodes even randomly just to see what happens. To move nodes, we can click and drag them directly. We can select multiple nodes either with a selection rectangle or by holding down the Shift key. To move nodes, we can, as in the 3D viewport, use the abbreviation G to invoke the grab command. We can call the scale function to scale the position of nodes so we can move them away from each other and squeeze them together, and with R we can also rotate them. Now we might ask, but what is the point of rotating the nodes? Well, it might come in handy maybe to make some order when we have a lot of nodes. To connect one node with another, we will just click and drag from one connector to another. This is a color type connector. We are going to put it in an always yellow connection. However, beware, no one forbids us to connect a yellow dot with a gray dot. It is not forbidden, simply this color scheme might give us results that we do not expect. In fact, look here. From yellow becomes purple, from yellow becomes gray, and instead from here, from yellow becomes yellow. So let's say Blender warns us. It says, warning, you're mixing apples with pears. I'll let you do it anyway though, as long as you know what you're doing. As you can see from the output of a node, we can connect to multiple inputs. No one prohibits us from making dozens of output connections, but on the contrary, to a given input we can enter only with one piece of information. That is, for example, if I now go to reconnect this data back into the input IOR, you will see that the other one comes off because there cannot be multiple pieces of information going into the same connector at the same time. This, however, doesn't matter if you remember, because that Blender will remind you automatically when you connect something that other one will detach. To be able to connect two different pieces of information in the same input, there are special nodes. For example, right now I'm going to insert an input node of type RGB. This is a node that allows us to output a color. Let's take green as an example. We delete the gamma node and duplicate this RGB node instead. With Shift plus D, we duplicate it, and this other one, for example, we give it as a color a blue. Here, how can we do to simultaneously connect this color with this color, since as input I can only give a connector? Here there are nodes that are created precisely to be able to mix more information together. In this case, we have to mix color type information together, so we will use a color mix. Mix color allows us to have two inputs, input A and input B, and have one output. In this case, we are mixing a green with a blue, and we can see the result within the 3D viewport. Alternatively, we can also see it within the preview. Let's try a test. Instead of green, let's try mixing red, and so on. You see that by changing the input, we get different color mixing. There are different types of blending. We have darken, multiply, color burn, lighting, screen, and so on. If you have used photo editing software such as GIMP or Photoshop, you will have already seen these types of blending. By analogy with programs in photo editing, there is this different blending. However, the default one is mix, and with the factor value we can go and define how much the color going into A should affect and how much the color going into B should affect. When factor value is 0, it will be 100% the upper input. When the factor value instead is at 1, the result will be 100% the lower color. The very interesting thing is that factor has an input connector. This means that we could use other information to go and mix the two colors. Let's take an example. I delete these two nodes. To delete them, we select them, and then we press X, and we go to insert a new node. We can do it with Shift plus A, but we can also do it by clicking on the connector and dragging to the left. You see that this cursor comes up with the plus that forewarns us that we are going to add a node. We let go of the mouse, and now we can go and search for the node we need. For this experiment, we are going to look for brick texture. This is a node that generates real bricks. We see them up here at the top, and by default there has been connected on the color value. You actually see that we need a numeric value, so we're going to connect on the factor value instead. Look what has happened. We have a texture of bricks. We will see later maybe how it works. We can scale it, we can define the size of the joints, the size in width and height of the various bricks, but the interesting thing is that we are given just the discriminant between the color green and the color blue. That is, right now we, using the two nodes, the input A and the input B, can go and say that in the joints between one brick and the other we want the color green, while the bricks we want them to be blue. Let's do an experiment. Let's have the bricks be red and, for example, the joints be gray instead. To make them gray, we put a saturation at 0 and choose the gray point. Here we have defined the material, of course very bare. We are really talking about the first steps. However, it is a non-trivial material. That is, we have already used two different colors and set them in two different areas thanks to the factor value. Let's try now to use another type of texture. So let's detach the brick texture and go to insert, for example, a wave texture. Let's see what happens. Wave goes to create real waves, in this case bands, but we can also ask to create rings, which then of course we can go and modify. The principle is always the same. We have two colors that go to mix depending on the factor in input. You see that the color factor works. In appearance it works exactly like the factor value, however it is more correct to use the latter. Well, for this lesson we will stop here. We have seen what nodes are, we have seen what types of data are, what types of information are passed between nodes, we have seen how to insert new nodes, connect them to each other, and mix information between them. Of course, we have not yet learned how to create materials. However, we have laid the foundation for parameter management. The exercise I propose today is to experiment, try to insert the nodes that are available in Blender. Experiment, try mixing colors, try using wave textures, Voronoi textures. Try everything there is, don't be afraid, because it is precisely by experimenting that you discover so much. Then of course in the next lessons we will see how to create real materials with some logic. Do some experiments also with parameters, for example, the scale factor. The scaling factor, we will see that the higher the number, the smaller the textures. Let's put, for example, 50 as a value, see how thin they became. Try varying the distortion. You will have already imagined for yourself what can be achieved, for example, with this kind of parameter. Let's try changing, for example, from red. Let's start putting a brownish color, for example. There you see? You already see for yourself that the possibilities are so many. So here you are experimenting, and I will see you again in the next lesson to really start creating real materials. I, as always, thank you for following me and see you again soon.